Hi, in this video, we're going to do some examples of differentiating expressions involving both sine of x and cosine of x that use the product rule. So we're going to start with this one, the derivative of sine of x minus x times cosine x. So the starting point for these is that, hopefully you already know, the derivative of sine of x is equal to cosine of x. So first step is that this is equal to cosine of x, because that's the derivative of sine. Now, it's minus the derivative of x times cosine x. Well, for that, we're going to use the product rule. So I'm going to write it as derivative of x times cosine x. And then on my next step here, we're going to use the product rule because that's x times cosine x. That is a product. So we are going to write this as, okay, cosine x minus parentheses, because there are two terms when we do the product rule. It is, doesn't matter what order you go in, but it's the first function times the derivative of the second function, factor I should say, plus the second factor times the derivative of the first factor. Or the reverse, either way, the order's fine. So first factor is x times the derivative of cosine. Well, let's write that out because I haven't done that yet. So times the derivative, we'll do red, times the derivative of cosine of x. We'll do that on my next step. So first factor times the derivative of the second factor, plus the second factor, which is just cosine of x, times the derivative of x. And I'll just write that out, times the derivative of x. Okay, now in my next step, I'm going to find those two derivatives, and then on the third step, final step, we'll simplify. So we get cosine of x minus parentheses x times the derivative of cosine x. Well, the derivative of cosine x is negative of the sine of x plus cosine of x times, well, the derivative of x is just the slope of that line is 1. Okay, and we can clean that up a little. Here, we'll make a little bit more room. We will get to those problems shortly, though. Okay, so we have cosine x. Now, let's do this. Let's distribute this negative and also just clean this up. So the negative of negative x cosine x would be positive x times sine of x. And then here we have minus cosine x. Well, turns out cosine x minus cosine x, those actually cancel. So this simplifies down to simply x times sine of x as a final answer. All right, next we're going to differentiate cosine squared x, okay? Before I do that, I want to mention there are two ways to do this. One is using the chain rule. The other is using the product rule. Now in this video, I'm going to assume that you maybe have not yet learned the chain rule, so I'm going to do it with the product rule, which means I need to write this as a product. So I'm going to write cosine squared x first as cosine x times cosine x. Okay, now it's a product. So when I do product rule, it's the first factor, which is cosine x, times the derivative of the second factor. Well, the derivative of cosine x is negative sine of x, plus the second factor, which is just cosine x, times the derivative of the first factor, which is again negative sine of x. So we have the negative of cosine times sine plus the negative of cosine times sine. It's the same thing twice, right? So that's negative 2 cosine x sine x. All right, and now we're going to do a fun one. We're going to find the 139th derivative of f of x equals to sine of x plus 2 times cosine of x. How are we going to do that? Well, we're going to find a pattern, obviously. We're not going to find 139 derivatives, okay? So let's see. Let's take, now the function itself you could think of as the 0th derivative if you want to. But I think what I'm going to do is call it the nth derivative. So I'm going to say when n is 1, let's find the derivative. So the first derivative would be f prime of x. And for this, it'll be simplest if we simplify as we go. Okay, so the derivative of sine is equal to cosine. And the derivative of cosine is negative sine, so that's going to become negative 2 sine of x. Okay, now I'm going to do n is 2. I think I'm going to just kind of go through the colors here. Second derivative, f double prime. Well, the derivative of cosine x is negative sine x, and the derivative of sine is cosine x, so that will be negative 2 cosine x. Don't see any patterns yet, so we're going to continue on. Okay, so now we're going to do third derivative. Derivative of sine is cosine, so the derivative of negative sine x is negative cosine x. And the derivative of cosine is negative sine. Here's where I want to simplify. Negative sine times negative 2 is positive 2 sine of x. Still no pattern. Don't see anything obvious here, so let's go to the fourth derivative. At this point, I'm going to put the little 4 in parentheses to indicate fourth derivative. Okay, derivative of cosine is negative sine, so therefore that one's going to become positive sine of x plus 2 times cosine of x. Look carefully. Do you see anything similar yet? Maybe you see it, maybe you don't, right? But this 0th derivative right here, right, is the same as this fourth derivative. Isn't that interesting? Well, since the derivative of sine x plus 2 cosine x, the original function, is the first derivative, then that means the next derivative, which would be the fifth derivative, is going to be the same as the first derivative because we're differentiating the same function again. Say the derivative of sine is cosine, and the derivative of plus 2 cosine x would become negative 2 sine of x. See, these are the same. So all we have to really do is figure out where does 139 fall in the pattern, because you're going to have this 4 repeating derivatives. 1, 2, 3, 4. Fifth derivative is the same as the first derivative. So if I kind of color coordinate again, right, the sixth derivative is I'm just gonna write it like this. The sixth derivative would be equal to the second derivative. I'm not gonna recopy it, I already wrote it. I'm just gonna draw an arrow here, right? And then the pattern continues. The seventh derivative, well, we're differentiating the same function. The sixth derivative is the same as the second derivative, so we're differentiating the same function again. So therefore, the seventh derivative of x is going to equal the third derivative, right? And this just goes on and on and on. And I'll write one more just to kind of complete the pattern here. So really all we need to do is figure out, where does 139 fall in this pattern? You know, you could just count to 139, but I'm sure we can use some basic math to simplify that just a little bit. Okay, well, since it's a pattern that goes by 4s, let's divide. What is 139 divided by 4? Okay, and we can pull out if you want, you can pull out your trusted calculator here for this. Hold on just a second. There we go. Okay, so we're going to do on here 139 divided by 4. Okay, so it goes in 34 whole times. I'm not really interested in the 0.75. That doesn't help me. We need to do remainder math here, right? So if I multiply 34 times 4, that means I'm going to repeat the process of 4 patterns 34 times. That's going to get me at the 136th. So I go 1, 2, 3, 4, 5, 6, 7, 8. The 136th derivative is going to be the fourth in line. It's going to be equivalent to these two red functions. So I could put ... The 136th derivative, right, would be equal to, would be equal to the fourth derivative, which is equal to the function itself, the 0th derivative, actually, equal to f of x, right? Okay, so then we just need to go, how many more? 3 more down the line to do 137th would be equivalent to the first derivative. 138th is equivalent to the second derivative. 139th is equivalent to the third derivative. So this triple prime of x right here, we can put equals to the 139th derivative of f. So we can say the 139th derivative is, if you want to rewrite it, would be for your final answer, negative cosine x plus 2 times sine of x. All right, so there's some examples involving derivatives of sine and cosine.